Hello guys, welcome to Fire Racer Workshop, and in today's video we're gonna be performing another experiment on Tinkercad, not on OrCAD, Tinkercad. So first of all, I'd like to tell you the aim of the experiment. So the aim of the experiment is we're gonna simulate a half-wave rectifier on Tinkercad. Many students were facing problems in installing this OrCAD software and their laptop was getting constantly crashed, the Windows was getting crashed. So therefore I'm recording this series in which I'll perform each and every experiment on Tinkercad as well as OrCAD. So I've covered most of the experiments on OrCAD. Over here, this is a playlist that you can view, and I've just linked this playlist in the description down below, or you can just click on the pop-up I button to check out this playlist. So let's just fire up our Tinkercad software. Now this experiment is just really easy to perform on Tinkercad. This experiment, the half-wave rectifier and the full bridge rectifier, both the experiments are really easy to perform on Tinkercad, and you'll just love these experiments. Now first of all, let's just go to all, select the all options in the components, and we're just gonna need, first of all, we're just gonna drag and drop our function generator. Let's just type in function generator. Then we need breadboard. So we're gonna use a mini breadboard because there are not a lot of components in this particular circuit. Now we are gonna type in diodes. So over here you can see we have two options. So we're gonna go with the normal diode. Let's just drag it, and I'm just gonna rotate it. So while you're holding the diode, just press R key, so that will just rotate the diode. So we want to place it in this particular orientation, so I'm just gonna place it on the furthest side. Then we want a resistor. So over here we've got ourselves a nice resistor. So then we'll just make our connections. Let's just select the proper color. Okay, so now what we need is an oscilloscope. So we're gonna type in oscilloscope. Over here you can see we have just got ourselves a nice oscilloscope. So let's just connect the positive to here and the negative one to the negative lead. We're just gonna color code this as black, and now we're gonna just set the time division to 4 milliseconds because the frequency that we are gonna be taking is about 60 Hertz. So that's the normal city frequency that we receive, and we're just gonna set the parameters to sine wave, and amplitude is gonna be around 10 volts, and frequency we have already set. So DC offset we're gonna set to 0.00 volts, and now we are all set. Let's just start the simulation. Now over here you can see our half bridge rectifier is just working properly. So if you want to see the input waveform as well, so let me just import another oscilloscope, and now you can just probe in your input as well. Let's just probe our inputs. So this is the input of the function generator. I'm just gonna probe that. So let's just color code it as red and set the time base as 4. So that's the time per division. So this is one division of the oscilloscope, so this is gonna be equal to 4 milliseconds. So start the simulation. Now you can see this is our input waveform and this is our output waveform. You can see the half wave rectifier is just working properly, and on my OrCAD software as well I was just getting the similar result. Performing all the experiments on Tinkercad doesn't mean that all experiments are gonna be easy. For example, this particular experiment right here, okay, so this particular experiment is the half wave rectifier. As there are no transformers that are available on the Tinkercad, so we have to perform this experiment in a bit of an unusual way. So over here also we haven't used any transformers because no transformers are available on Tinkercad. So over here as well, so this is for the half wave, this is for the center tap rectifier, and over here you can see we have used the two op-amp ICs. So one is in the inverting configuration and one is in the non-inverting configuration to give us the voltage of like to give us the center tap voltage kind of thing. So it's just like generating two AC sine voltage that are 180 degree out of phase. So that's why we have to use the op-amp IC. and over here you can see this is the rectifier circuit, and here is the output waveform, and here is the input waveform. Again, we are just supplying it with 17 volts peak to peak voltage, and here is the split power supply. So no, performing the experiment on Tinkercad doesn't mean that it is always going to be easy. Full bridge rectifier will be easy on Tinkercad because you don't need to create such kind of power source in that particular experiment. But for the center tap rectifier, yes, the complexity is gonna be there. But like after the center tap rectifier, no other experiment is like that difficult on this particular software. So this is all for the video, and thanks for watching. I'll see you in the next video. Don't forget to like, share, and subscribe to my channel. See ya.